Hello children, welcome back to the online classes season 2. Okay, so now we are going to see about the important topics what we have to recall and learn for the forthcoming examination. Okay, like the previous videos, don't try to skip the contents. Very basic contents only we have given. So whatever you have learned throughout this year, that is what we are going to recall now. Okay, so kindly don't fast forward the videos as you usually do it. Okay, so kindly follow every content what we are saying, right? Okay, first content what I am going to discuss over here is from the first lesson, measurement lesson. Okay, first how many quantities we learned? Mainly we have two types of quantities, correct? What are they? Fundamental quantities and derived quantities. And children, depending upon this content, we are going to conduct a small test as the circular came to you, right? And mostly the test may be in an objective type. Choose the best answer or fill in the blanks. Okay, mostly, but few questions will be asked as best answers. Okay, so whenever we are going to revise now, whatever may be the subject, so take notes based on your answering for 1 mark questions. Okay, so listen to the class in that content and that context. Okay, right. So how many fundamental quantities we have? 7 fundamental quantities, and we have so many derived quantities. What are fundamental quantities? The quantities which cannot be expressed in other terms of other quantities. They are called as fundamental quantities. Take page number 2 in your textbook. It shows us there are 7 fundamental quantities. What are they? Length, mass, or if have you taken your textbook, page number 2, with your pencil in your hand? Pause the video and take it. Okay. What are the quantities? Come on, say. Length, mass, time, temperature, current, then luminous intensity, and what is the amount of substance. There are 7 fundamental quantities. And what are the units? That also you have to learn. Right? Next. And what are derived quantities? Quantities which can be expressed in terms of other fundamental quantities are called as derived quantities. This definition is not needed now, but you just know there are 2 types of quantities, fundamental quantities and derived quantities. There are 2 examples given for derived quantities, area and volume. Area is expressed as length into length, right? So area is expressed in terms of length and length, but length is a fundamental quantity, correct? So now this quantity is derived from a fundamental quantity called as length. So one quantity expressed in terms of other quantity. So they are called derived quantities. So volume is this 3 times length. What is the formula for volume? A cube we say, right, for a cube. So A means what? It is a side, length. Length into length into length. Length is a fundamental quantity, right? So volume is one quantity is expressed in terms of other quantity. That's why we say this is a derived quantity. Okay, so are you clear about fundamental quantities and derived quantities? Right? So definition is not needed here, but know how many fundamental quantities are there, what are their units. Mass unit is kilogram, length unit is meter, SI unit only you should know, right? Time unit is second, temperature unit is Kelvin, current unit is ampere, amount of substance unit is mole, luminous intensity unit is candela. Like that, all the units you need to recall, right? Now along with this, there are 3 system of units. We learned it already, right? What are they? MKS system, which is otherwise called as SI system. SI system stands for International System of Units. Remember, recall all those points. Here in MKS, meter, kilogram, second. CGS, centimeter, gram, second. FPS system, foot, pound, second. In all these 3 systems, first stands for unit of length. Second, kilogram, gram and pound stands stands for the units of mass. Second, it stands for the unit of time. Clear, children? Right. Now in the last content of first lesson, we have this topic, rules for rounding off. For if we take a number, right, if we get a number in a measurement, right, for example measuring the length of a room, right, weight of any substance, right, we will get some number. It will be like in decimals or it will be in a greater way. It will go on in decimals, right? After decimals we can have 4 decimal, third, 3 decimals and all. If you want to round off that, what are the rules we need to follow? That is what we are going to see, right? First, what is the first step? Decide the last digit to keep. For example, if we have 72.74678, okay, we have after decimal we have 4 numbers here, right? So we have to first decide up to what number, up to what digit we are going to keep after the decimal. Are we going to keep 2 numbers or 3 numbers? First we have to decide that, right? Depending upon the need of measurement. Now here I had explained the examples of rounding to 2 digits after the decimal. Okay, so now first what is the first rule? We have to decide what is the last digit, how many digits we are going to have after the decimal or before the decimal, right? So it is depending upon the need of measurement. Okay, next one, leave it the same if the next digit is less than 5. For example, I have taken one number here, you can zoom and see it, 72.742. After the decimal, how many I have? 7, 4 to 3 decimals I have. Even if I have 7 decimals over here, what is my question? I have to round this number to second decimal place. That is my question, right? To round off that particular number to the second decimal place, what I have to see? I have to see just up to third decimal, right? So first, last digit, what is the decision now? Up to second digit. If I am going to round the second digit, up to second digit, I have to take one more digit, third digit, to round off. Okay, now up to second digit I need to have, first I have to see the third digit. Third digit, now read the rule, leave it the same. Leave it the same means what? Up to second digit. Till there only we are going to round it. Okay, 72.74 we have to leave when if the next digit is less than 5. After the second digit, we are going to round to second digit only, right? Next digit, second digit's next digit, right? That 2 is less than 5. Obviously 2 is less than 5. So what we have to do? If the next digit to the rounded off digit is less than 5, we have to leave it as it is with the second decimal. Don't worry about the third decimal places or fourth decimal place, 5, 5th decimal, whatever it is. Leave with the second decimal. Okay. For example, if you are going to round with the fourth decimal place. Okay. If fourth decimal place means fifth number you have to see. Fifth digit is less than 5 means leave whatever comes after the fourth decimal. Write the number as it is up to fourth decimal number. Clear, children? Right. This is the second rule. Third rule, add 1 if the next digit is greater than 5. Now till what digit we are going to round off? Second digit. Right? Now after the decimal. Here third digit is greater than 5. So what if it is greater than 5? What we have to do? We have to add 1 to the last digit. What is our last digit? Second digit. So see, there is a third digit 7. It is greater than 5. So if it is greater than 5, add 1. So add 1 to the previous number. What is the previous number? 4. If we add 1, what we will get? 5. So 72.75. Clear, children? These 3 points only will be there in your book. In the third point, they would have said 5 or greater than 5 they would have told. But read like this. There are 2 other points. So along with the textbook points, these 2 points also to be added. These 2 points you will learn in your higher classes as per your textbook. but now itself you learned it. Okay, now what are the three rules? First, decide to which digit we are going to round off, right? Then, next digit you take into consideration. If the next digit is less than 5, leave as it is. If the next digit is greater than 5, add 1 to the decided digit, rounded off digit, right? Then write the number. If the next case greater than 5, less than 5, if it is 5, what we are going to do? That then two cases arises. If the next digit is 5, add 1 to the previous number. Previous number means where we have to round off. If it is an odd number you know, 1, 3, 5, 7, right? 9 also, right? Now we are going to round off up to second digit, right? Right now the next digit is 5, right? Intermediate case, not less than 5 or greater than 5. If it is going to be 5, then what is the procedure we have to do? See the rounded off digit. If it is going to be an odd number, add 1 to it. Then what will be the answer? 43.48. Similarly, if the next digit is 5, leave it the same if the previous number is even. Right? See the number, the last digit is 5, but the previous number is even. Even means we have to leave as it is. 24.32. It is going to be add 1. Clear, children? Right? So this is a very, very important question. If it is no 5 marks is going to be asked for this test, right? So if as it is not going to be 5 marks, so we will give numbers and we will ask you to round the numbers. Okay? Know the rules and understand the rules. And there are some examples we have given in your PDFs, what we have done in the last video classes, and in your classwork you will have it, or else you will have in your textbook also that numbers you can do it as examples. Okay, what are the rules? First we have to decide what digit we have to round off, and if it is less than 5, leave as it is. If it is greater than 5, add 1 to the previous number, that is to what number we have to round off, and if it is 5, leave the same if it is even, add 1 if it is odd. Add 1 if it is odd. Okay, remember that. Right, next one we are going to see effects of force. Right, if a force is acting on a body, right, how much effect, what will be the effect of force on that particular body? What are the factors which will decide the effect of force? For example, if we are washing clothes, right, so we will do it like this, no, when we are washing a very tough clothes, no, right, we are giving this much amount of force on the cloth. Hand wash only, not machine wash, right? Right, when we are washing like that, what are the factors which will decide the effect of force on the body? Right? First, magnitude of the force. What is magnitude? I told you. Magnitude means the numerical value, the amount of force. Is it a bigger force or a smaller force? Right? How much force will be you are washing that cloth? Right? So, and area of acting. Where on how much area you are applying the force. Depending on these two factors only, the effect of force will be created on a body. Clear, children? So what are the effects of force? It is not, these 2 points are not the effects, children. The factors which will decide the effects of force. Okay, I will clearly give in the notes. Okay, don't worry. So what are the factors which will decide the effects of force? Magnitude of force and the area to which the force is applied. Okay, very, very important points. Alright. So then we are moving to the next lesson. From here itself we had moved already. Now Pascal's law, very, very important point. When I was teaching this, I have told you this about this Horlicks ad. One girl with a family would have got caught in that open road due to that car tire puncture, and this girl will come out, one elder girl will come out, and she will replace the car's tire with another normal good one tire, right? So in that, if you see that ad, you can see normally what the jack-like appliance will be kept under the car to lift the car or to support the car, right? So that lift, which it will be called as hydraulic, a miniature form of hydraulic lift, right? What does that do? It will contain one liquid column, right, inside it, or an air column it will contain. What it will do, as we rotate it, the liquid column will get that pressure, that column inside that appliance will get that pressure, right? So that pressure will spread out equally on the car. So that may be a smaller substance, right? This much height only it will be, a small height only. So if we do that, when we lift it, right, what will happen? The pressure will be applied on the full bottom area of the car, right? So that is called as hydraulic lift. I would have explained it in the notes, but I have not explained here. That is based on Pascal's law, right? Have you ever watched in automobile service stations, in car service stations? Have you seen this? Car will be standing on a greater height, taller than the person who was servicing it, right? Have you ever watched it? The car will be here and the person will be standing and servicing the bottom parts of the car. How they will lift the car is based on this formula only, for this law only, Pascal's law. What is that law? The pressure applied in a closed system of liquid spreads out equally. If a liquid is there in a liquid closed system, closed container, if a pressure we apply it, the pressure will be, where we apply, there only the pressure won't be applied. It will spread out in all directions. Okay. For example, when sometimes if you don't have time to iron the cloths, what we will do? We will fold the cloth very nicely and we will keep it under one heavy weight, right? So what we will do? The pressure is applied uniformly on all areas. Like that, if a liquid is there inside a closed system, and if we apply a pressure on it, and it will spread out in equal direction. A simple example is given in your book. I had done it when I was teaching this. Take a balloon, right? Balloon, blow it and fill it with water, right? So and close it with a rubber band, tie it with a rubber band. If a small holes are pricked on the balloon, what will happen? If you press the balloon at one side, water will come out in all directions. Where we press, there only the water should come out. No. So it won't be like that. Even when we press at one point, pressure is applied on one area, but it will be spread out in all directions because liquid is in a closed container. That activity is there in your book. Read out that. I had also done it. Right? Next one. Pressure. We are moving to pressure. What is the meaning for pressure? Definition for pressure. Force acting on an unit area is called as pressure. Remember, pressure is the force acting on an unit area. What is the formula? Pressure is equal to force by area. What is the unit? Force unit is Newton. Area's unit is meter square. That meter square is in the denominator. When it goes up, it goes as m power minus 2. So what is pressure's unit? Newton per meter square. Minus how we have to read? Per. Newton per meter square. We have another unit for pressure. We call it as Pascal. P-A-S-C-A-L. Right? So when we are writing as P-A-S-C-A-L, first letter should be in small letter. When we are writing as P-A like this, first letter should be in capital letter. Right? Remember this. Okay. Here this formula shows P is equal to F by A. P is in numerator, F is in numerator. Right? Numerator are directly proportional. So when force increases, pressure also increases. Remember this? Okay. Pressure and the area are inversely proportional. If area increases, pressure will decrease. Area decreases, pressure will increase. So inversely proportional. P and F are directly proportional. P and A are inversely proportional. Right. So based on this, we have so many applications in our daily life. What about your school bags? School bags, we have thicker straps here. Right? Broader straps. Broader means area is bigger. If area is bigger, pressure will be smaller. So you will not have that much pressure on the shoulders. You will not have that much pain on your shoulders. And right, nails. When we just nail on the wall, nail a nail on the wall, what we have to do, the nails are made sharper, right? If it is going to be sharper means area is made smaller. If area is smaller, pressure will be more. So it can easily penetrate into the wall. But what about the other end of the nail, which will be made as a round? Have you ever seen it? On that round only we will hammer, right? That hammer will not be sharper, it will be blunt and round, right? So if area is more, there pressure will be less. So with less pressure we can hammer it. For us pressure has to be less, but for nail to penetrate into the wall, the pressure need to be more. See how much deeper concept of physics in just hammering the nail, correct? Next one. And some more examples you can get in this slide. And new examples I will ask in the book and in the classwork also, PDF also I have added some more examples. Okay? Right. Next, what is surface tension? It is the amount of force acting on a unit length on the surface of a liquid. Right? If we have a vessel of liquid, right? That liquid will have a surface, right? On that surface, some force will be acting. On a particular length, how much force is acting? That is called as surface tension. So what is its formula? Surface tension is equal to force by length. Okay, what is its unit? Force unit is Newton, length unit is meter, but that meter is in denominator. When that goes up, it will go as Newton per meter. Clear, children? So this is surface tension. What is friction? Friction, for example, if I move the hand like this, if I just move like this, the force acting, I can feel that heat, hotness, right? The force acting between two moving bodies. One body moving on another body, right? Doors, right? Vehicles moving on the roads, one body moving on the other body. The force acting between those two moving bodies is called as frictional force. This much alone enough as of now, don't go much detail into it. This friction is divided into three types. What are they? Static friction, sliding friction and rolling friction. Right? Static friction means when two bodies are at rest, the friction acting between these that two bodies. For example, if I do like this, my one hand and another hand is both are at rest, right? So the friction acting between these two is called as static friction. Sliding means what? If one body slides on other body, sliding on other body, right? For example, if I drag a bench by lifting it, right? So like this, right? So when if on the floor, if I move any object like this, so this body slides on the other object, right? That type of friction is called as sliding friction. What is rolling friction? We have wheels on our suitcases, right? So we will drag like this, right? So that friction is called as rolling friction. So of these three frictions, which is greater? Static friction is the greatest. Sliding friction is an average friction and rolling friction is the easiest and smaller level of friction, right? So static friction is greater than sliding friction is greater than rolling friction. Clear, children? So these points alone is enough for friction. Now we are moving to the lesson light, right? First we have to know mirrors. What are the two types of mirrors we learn? Plane mirrors and spherical mirrors. Plane mirrors is what we use at home, right? So it will give what type of images? It will give virtual, direct, laterally inverted image. Laterally inverted means left appearing as right and right appearing as left. So it is the characteristic of the image formed in a plane mirror. What about spherical mirrors? What are the two spherical mirrors we have? Concave mirrors and convex mirrors. Concave mirror will converge, bring all the light rays at one point. Convex mirrors will diverge. So concave mirror is a converging mirror Convex mirror is a diverging mirror. All these points note down. Don't see the video as if you are seeing master's film anywhere, clipping from that film. Pause the video and take down the notes. Concave mirrors are otherwise called as converging mirrors. Convex mirrors are called as diverging mirrors. Correct? So where do we use concave mirrors? Shaving mirrors. Where we in saloons and all, they will use it to get a very clear image. Right? And we have solar cookers. Solar cookers means all the light rays will converge at one point to make the heating very faster. And we use in torches and telescopes. Torch, all the light rays has to be converged at one point. No. So for torches and telescope, we use concave mirrors. And where and all we use convex mirrors? Rear view mirrors, or vehicle side mirrors. Right? And sharp turns on roads. When we take a sharp turns on the roads, on the turn they keep a mirror to see the that side vehicles. Right? So there we use convex mirrors. Very, very important points. So these questions can be asked. Shaving mirrors uses dash mirrors. Rear view mirrors are convex mirrors. Like that question can be asked. Okay. Now image formation. In this lesson, right lesson, you have a tableau column. Do you remember, children? Right? So that tableau column, not to learn all the details now. Just know what are the type of images and size of the images will be formed. Right? Now you see what type of images will be formed by concave mirror. In the tableau column, have you taken in your light lesson? Right? So concave mirror means all the images will be real and inverted, except the last sixth part. Sixth part alone is the virtual and erect image, where the position of the object will be between F and P. That alone will give you virtual and erect image. So the question can be like this. Concave mirror gives both real, inverted, virtual and erect. Right? What about the size? What about the size of the image formed by concave mirrors? It will start from highly diminished, same size, enlarged, highly enlarged, enlarged. That is how your tableau column goes. So concave mirrors gives all types of images. Right? So it gives a very, very diminished image, same size image, enlarged image, virtual, erect, real, inverted. So all type of images will be given by concave mirror. But what about a convex mirror? Only two positions we have. Right? So it will give very diminished image only, and that two images are also virtual and erect. That is how I have written virtual, erect and diminished. So these two tableau columns are in page 25. Right? So next one we are moving to refractive index. What is refractive index? It is represented by a letter mu or n. It is given in your book. I will give in the notes also. So right? So refractive index is formula mu I have written here. U we have to write and we have to extend it at one side. It can be sometimes it can be represented as n also. N, small n. Both the symbols we can use. So what are the formula? Refractive index is the ratio between C and V. What is C and V? C is speed of light in air medium or vacuum. Right? What is V? It is one particular medium, water medium, solid medium, gas medium, like that. But what is small c? It is speed of light in air alone. What is its value? Remember, note down, 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. Okay, this is formula for refractive index. See children, this is also speed, this is also speed. So speed get cancelled. So refractive index will not have any unit because it is a ratio of similar quantities. Clear? What are the similar quantities? Speed. Okay. Right. What are the other formulas? If here generally it is written like this. If there are two mediums compared. For example, if first medium is glass, second medium is water. If we have to find the refractive index of water with respect to glass medium, any two mediums, children, take like that. Okay, then what is the formula? It is mu2 by mu1 or speed V1 by V2. Okay, so these three are the formulas for refractive index. Sums will be based on this, even formulas will be asked on this. Right, so in your PDF notes I will do some sums and send to you. Okay, right, what is dispersion now? So I have shown you that prism in your classes, right? Do you remember that, children? So that prism will what is that? It will split the white light in 7 into 7 colors, right? So that 7 colors will be in a pattern of violet, indigo, blue, green, yellow, orange and red, right? Prism, I don't know whether I had shown it in the class, but it is a triangular glass body, right? So through which light will pass through. While I was teaching this class, I would have shown it in the online video, right? So just check it out. So prism is a triangular glass crystal. If I send white light or sunlight through it, we can get back the pattern of 7 colors of Vijaya. What are they? Violet, indigo, blue, green, yellow, orange and red. So that process is called dispersion, and that pattern of 7 colors is Vijaya. Sorry, spectrum. SPECTRUN. Okay, so we have different types of spectrum here, but what we get as rainbow, no, during rain and rain on a hotter day, we will get rainbow, no. So that is an example for natural spectrum, very important example. Okay, so tie up the notes, copy the notes. Your notebooks will be asked for correction, right? Especially 8th C students, complete your classwork. So many of you have not completed your classworks, right? Yet to be checked, some people's notebooks. So when classworks are asked for corrections, it has to be submitted. Sorry, it must be submitted. Okay. So we have completed 10 concepts here. 10 more concepts are there, but we will see that in part 2. Okay children, all the best.